So I've been working with backend stuff a lot, still working with mobile, but I've built some backend for some mobile apps, like the one for My Smart Blinds. And I've interacted with IoT stuff. We built things for Alexa integrations and Google Home and smart things. So it's kind of all of this infrastructure with IoT, mobile, and server cloud backends. And just to get started, I'm going to go over the prereq. So if you didn't go through the prerequisites and get stuff set up, don't worry about it. I'm going to talk about it briefly, but it would be distracting probably for you to try and do it during the presentation. So just follow along. I produced quite a bit of documentation so you can go back and get this set up. But the prerequisites, we're doing this with Node.js. You'll need an AWS account. It requires a credit card, but they have this awesome free tier. A lot of features in the first year and some free tier features that go on forever. So if you're using it under a minimum, and a lot of their serverless stuff have a free forever tier if you use it under a certain threshold. Then you have your AWS CLI and the serverless framework. Serverless framework is at serverless.com, and serverless is kind of a misnomer because we call all these technologies serverless, but of course there are servers, and basically it's a marketing term for fully managed, so you don't have to manage your own servers or scaling and stuff. So, and then the serverless framework, they just make things easy. Now, we're focusing on AWS, but they integrate with all of these different service providers. However, AWS support is still some of the most robust because it's been around the longest and has some of the most robust features. Although Google and Microsoft are kind of catching up in some ways. All right. I like to use VS Code. This is my preferred code editor. Any questions about prereqs? Anybody had any trouble getting things set up as they were getting started? All right, let's jump in. So I put together a Hello World app. And the first thing we're going to look at is your serverless.yaml file. And as you get started with the serverless framework, they have these templates. You can just do a command line to create a new project, and it'll create a pre-populated serverless.yaml file. I have this one really well documented. Every serverless project is called a service, and it has a name. And that just needs to be unique for your AWS account. And then here we have it with AWS, the runtime. It's interesting, there's a lot of different runtimes that you can use. Dave was asking me before if I'd played around with the Swift runtime. And just so you guys know, here is a list of official runtimes that are supported by AWS. They have Node, Python, Ruby, Java, Go, .NET. But just this last year, they rolled out support for custom runtimes. And so anything that, so people can package up a runtime. If it runs in a Linux environment, you can run it on Lambda. And there is a Swift runtime. There's a Rust runtime. And anyways, you just can go Google it and you can include your own custom runtime with your Lambda function and pretty much do whatever language you want. So here, we're specifying the AWS Node runtime. You can have different stages. So I can have a development, test, production, V1, V2 stage. And these are all separate deployments that deploy a complete set of new resources for each stage. So that's great for testing and everything. Memory size timeout, I won't go into that, but all right, so the function section, this is where a lot of the meat is. You have a name of a function, a handler. So that points to the actual code that's going to execute the function, and an event that's going to trigger the function. So this one has an HTTP event, which hooks it up to a service called API Gateway. API Gateway is just, so because this is serverless, you don't have a server just sitting there running, listening for connections. AWS has a service called API Gateway that you can map, that you can route things to, and it is there listening for connections for you. And when it gets a certain connection at a certain endpoint, a URL, it'll trigger your Lambda function. So that's what we're going to.
Can I ask a question, Josh?
Of course, yeah. Anybody can ask a question anytime.
Is that really all it takes to get API Gateway to actually route to your Lambda function?
Kind of.
From serverless. Okay.
From the serverless framework, all you need is this. That's it.
Wow.
When it comes to so serverless is shorthand for what's called CloudFormation. CloudFormation is a templating language and service from AWS to deploy resources. And so they have these stacks, and I can deploy many, many things all at once, and you can automate and everything. Serverless makes this easier for API Gateway and Lambda based things, so that so it's way more concise and way easier to work with. And I'm going to show you an example here in a minute of the CloudFormation that this small thing outputs. Okay, so, oh, and by the way, I have a lot of these further readings. We're not going to get into many of these here, but you can go in here. They're really, I've tried to put together years of experience here to get you guys set up quickly, and also to give you some depth if you want to really get into this sort of stuff. So, all right, so here's what a handler looks like. This is just plain JavaScript, or plain JavaScript in Node.js, where they have their modules. So I export this hello world function, and it takes an event and a context, and the event syntax is just AWS's way of passing information to a Lambda function. The API Gateway event has things like HTTP headers and query string parameters and the body and authentication information. In fact, I did a little link here so we can look at an example. And this is one of those things that these little links are helpful for, because finding an example of this event is actually a little hard to find with the AWS documentation. It's there somewhere, but I can never find it. So again, like I said, it has all the headers, it has the HTTP method, and all the information that you'd expect to come with an HTTP event. All right.
So in your YAML file where you specified that the handler was index.hello world, so
yeah.
that's index, the name of the file, and then lopping off .js,
yes.
And then the exported function name?
Yep, that's correct.
Okay.
And in fact, this hello world, if I go back to guide and go to examples, there's an hello world one, and that's the example that we're looking at. We're just looking, so in my README, in the markdown document, we're just looking at parts of it, but the full example is here. So this is the index.js file. That's the serverless.yaml. These two files, you don't need. I actually just put them there for as an example. So this hello world example is only these two files. Great question. So here I'm taking from the event the query string parameters. This is a little JavaScript shorthand. It's similar to the nil coalescing function in Swift, where if this is defined, then I'm going to go to this next thing, and get the name. If this isn't defined, I'm going to populate unidentified user. I think in the actual sort, I said world, so say hello world instead of hello unidentified user. So I create a body, and then I create a response, a HTTP status code of 200. This header thing is just to show you that you can set headers. This is not a header of any significance. And then the body just has to be a string, so I stringify the JSON, or I serialize to a string, and I return it. Now, we'll get to the deploy step in just a minute. When I deploy, this is what I get. I get an HTTPS connection to API gateway. I get a Lambda function. I get a CloudWatch log group and a places to see all the console logs. And I get some permissions. So basically, the Lambda function, if you just create a Lambda function, it can't do anything because it needs permissions of who can invoke it and what it can interact with. So serverless, the framework, it defines the permission that the API gateway configuration can invoke that Lambda function, and that Lambda function can write to that CloudWatch log groups. So if I look at, bad link, I'll have to fix that. So let's go back to the example. So if I look at what that created, it created all this cloud formation that they have an S3 bucket that it deploys the code to. It has that log group. It has this IAM role, that's identity and access management, so that it allows Lambda to assume a role that can do this stuff. Anyways, so, and these are all the role policies. This is the definition for the Lambda function itself, and so on and so forth. This is configuring API gateway. So going back to your question, Derek, there's some approaches. I've talked to people that have just tried to set this sort of easy thing up with the AWS console and got stuck because it was not easy. But serverless framework makes it easy. And if you follow this guide and the guides that they have and some of the resources that I linked to, it can continue to be pretty painless. All right. So I'm going to make.
If I could chime in really quick.
Yeah.
I just want to echo what you just said about how easy serverless makes this, because in a previous life, I was a web developer. I don't like to talk about this or admit this, but I used to be a web developer doing like server management and stuff, and it was a complete pain in the butt. And AWS makes things a lot easier, but it's also really hard to understand just like all of its parts and everything that it does. So when I was looking to build the backend for my own app, I came across serverless, and it really is just this matter of like listing out what I need in the YAML file and then running deploy, and it takes care of everything. It is really nice.
In fact, while we're talking, I'm going to do that right here. So I'm going to go say I'm in the hello world example. So I'm going to do serverless deploy, and we'll see that. So a little side note about AWS. AWS is awesome. You can do so many things. It's super configurable, it's super powerful, and it's super complex. So it has a pretty steep learning curve. And everything is documented, but it's hard to find everything that you need to do. They have these AWS certifications and all sorts of stuff to help navigate all the complexity that is AWS. I've learned a lot of that complexity, but I still way prefer serverless and some tools like this. That said, there are other services that do a better job as far as managing complexity. You know, Google's Cloud Functions and Firebase and stuff like that has better tutorials. It's easier to get up and running. But I stick with AWS because I've just been using it for a while, and it does everything that I've wanted to do, and is really, really powerful. Anyway, so I just deployed this. It gave me this output. It says that I have, so this is my API gateway endpoint. So if I go into a browser and hit that, it says, so that is an actual Lambda function being triggered by an API gateway event. Remember that we did a query string parameter, so I can go name equals Josh, and it'll say hello Josh. So that's our function. All right, and that's all the complexity that we hid. So was there anything else here in the, oh, oops, I need to go to the hello world markdown document. Okay, so deploy, yeah, we just deployed it with that command, serverless deploy. We looked at the cloud formation. All right, any questions? I'm gonna jump on to the next section. So this section is, we're just kind of do a quick overview. This is for you to read later. I just wanted to give you an idea of all the stuff you can do with AWS Lambda. So we have, and of course I wanted to point out some of the limitations. AWS Lambda is limited in size, memory, and execution time. So if you can fit within those constraints, you get auto scaling, you get pay per use, all these really nice things. If you can't, it's not the right tool for the job. All right, so you can call a Lambda function directly, and I point out that you can do this from the iOS and Android SDKs, but I don't recommend that because I personally kind of hate their mobile SDKs. So I much prefer doing an abstraction like an HTTP gateway interface to it. And let's see what else. Oh yeah, Derek, you mentioned AWS Amplify. I'm not going to be teaching you that. AWS has some tools, Amplify and a tool called SAM, that they've used to try and address this complexity problem and make their stuff easier to use. While it is easier than it was before, it's still not as easy as serverless. So every single time I've played around with those tools, I found them more complex than I'd like. And so I haven't really gotten into them as much. Okay, we can schedule events. So I can just have stuff run on a cron job. So we've talked about the API gateway, REST API. That's the one that I just showed you and the one that we'll be continuing to work with. They have this new thing called HTTP API. It's basically optimized for some specific use cases. I just linked to the docs here. WebSockets. WebSockets is cool. They introduced this just like a year and a half ago. They will maintain a persistent WebSocket connection for you and just call your Lambda function as needed to handle events. And you don't have to worry about scaling, or all of this stuff is typically pretty hard to do with WebSockets. And with my project, I actually include WebSockets in it as a subscriber. So I'll show you a little bit more of that. Kinesis is an event stream. DynamoDB, you can get a Lambda function called whenever a table is modified, like something is added. Same thing with S3, if somebody adds a file or changes a file in S3. SNS and SQS are, well, I shouldn't quite compare them as the same thing. SNS is a pub sub notification service. This is what you use to send push notifications out to mobile devices. You can also use it to send emails or text messages, or just to message between services. So it's pretty flexible. And SQS is specifically a queue. And it's not hooked up. It's not naturally hooked up to as many things. It's just a basic queue that's managed. Application load balancer. So if a certain threshold is met, it'll call a Lambda function, and you can scale your load or handle something or reroute your traffic. Lambda is a good place to implement Alexa skills. I've done that before. So when somebody says, "Hey Alexa, run this app," it'll be run by a Lambda function. Oh my goodness, that's my Alexa responding to me saying its name. All right. AWS IoT is cool. I've worked with this. It's basically a secure pub sub interface for Internet of Thing devices. So we've used this with hubs, and I'm using it with the autonomous lawnmower, and it allows you to push and respond to events. Okay, I'm going to skip this now, so you get an idea. You can do lots of different events. We're focusing around API Gateway. Okay, so here, I'm going to go to the next example, which is Hello World TypeScript. And Node projects, plus a lot of modern JavaScript projects that like to use Node-style package management and then do fancy things like Webpack, so it actually goes into a single JavaScript file that will run in your browser. Use something called package.json, and that defines your dependencies, your things like configuration, scripts, and different things. If you use CocoaPods, it's similar to a pod file, but it's I haven't used the equivalent yet with Swift Package Manager. But anyway, it just kind of defines your project and its dependency. So if I go, and here I say, let's use Yarn. Yarn and NPM are both package managers. So I'm going to do yarn init. And this is going to walk me through creating my package.json. Now I already have one here. So when I rerun it, it just lets me change it. So it's already, this is my project name, version. I can give it a description. Entry point is index.ts. If it were in a repo, well, I could actually say, this is my repo. Author, license, and there you go. So I have a package.json here in this directory. And now I can add my dependencies. So I only have one dependency, and that's called source map support. What that does is when it logs stuff, just a little bit of background on TypeScript. TypeScript, oh yeah, let's jump to this really quick. It's just a preference. It gives you some nice typing and syntactic sugar, but warning, it is really just JavaScript. It's not a strongly typed language. It gives you types, it gives you some nice developer tools, but at the end of the day, you're still working with monkey patching. And
we like to call it wishfully typed.
Wishfully typed, yeah. If you produce all the code yourself, then TypeScript can really help. If you don't, then you need to remind yourself that what was passed in from the other library or the HTTP connection or whatever could be anything. All right, so just a little caveat. I like TypeScript. It makes my experience with JavaScript better personally, but it is not really a typed language. All right, so source map support, that makes it so that, so TypeScript compiles or transpiles. It's, turns out it is a type of compilation, transpiling is, but it compiles to JavaScript. And so if you just output your JavaScript logs, like if you output an error that does a stack trace, and it's going to point to your JavaScript file instead of your TypeScript file, which isn't the same line number as in TypeScript. So this source map actually makes it so that it outputs to your original TypeScript file line number when you're looking up errors. And then I have a bunch of dev dependencies. These dependencies are excluded when you deploy. So you install types. That helps your code editor be able to do autocomplete and help you find stuff. And then we do the serverless stuff. So we install serverless, a plugin called serverless offline, and a plugin called serverless plugin TypeScript. And we install TypeScript itself. This TypeScript plugin helps with helps make the TypeScript experience so I don't have to compile it all the time. It just makes it so there's no setup and it just runs. All right, there's some stuff you can ignore in your Git history if you're tracking this with Git. There's a .serverless and a .build. Although .build, the TypeScript plugin gets rid of that. It only uses it when you're running it offline or when you're deploying. And Node modules. So Node is infamous for their dependencies. I know Dave and others have talked a lot about minimizing your dependencies and that good practice. Well, a lot of JavaScript developers just throw that out the window. And you can include one dependency in Node and have it populate hundreds because of their sub-dependencies. And so it's a bit ridiculous. And there's no reason to track that in your source. Okay. We're going to add a script section. So we're going to add a start script and a deploy script. I'll show you what this looks like. If I go to my example, let's see, we have the TypeScript example. We're going to package.json. So once you have this all set up, it has my dependencies there, it has my dev dependencies, and it now has my scripts. So I can, before I get ahead of myself, let's do the next step where we actually change the code. We need to do a couple other things. We need to add these plugins that we installed so that the serverless, in the serverless.yaml file, so it knows about it. And let's just walk through the new TypeScript index file. So right here, this line, this is just importing some types. And let me show you what this gets me in my editor. So this event is an API gateway proxy event. So if I command click this, I can see that this is how it's typed. And the VS Code editor is really nice for just being able to look at these types. And it shows me what my return type is. By the way, though, I had to add those types myself because I know what they're supposed to be. And there's not a good definition unless you look at other people's examples for just an arbitrary function that you set up like this, because some unseen library with API gateway is actually calling this code. We don't get to interact with it ourselves. Remember how I did that and? TypeScript has just, so this is like the optional syntax in Swift. I can just do a question. So if that's null, it won't give me if it's null or undefined, it won't give me an error. I can declare the types like that, or it can just infer the types. All right, so I included an offline plugin. So I'm going to now run yarn start, which in my package.json calls serverless offline start, and it's compiling my TypeScript. It compiled it, and serverless offline says that this is now ready. So here is my local function. So this is not deployed. Oops, I need to go in the browser. this is not deployed. This is just running locally. And we can see that when I hit it, it's showing me all my logs. And so I can have a local development environment. And what Serverless Offline does is it emulates API Gateway and sometimes some other things so that you can run things locally. I can stop that, and I can do a yarn deploy if I want to deploy this. And now it'll deploy to the cloud. Okay. Now we're going to get into some more meat. AWS resources. So serverless is focused around API Gateway, some other Lambda events, and running Lambda. So anything that triggers a Lambda function, serverless framework gives us some nice shorthands to do. Anything else, it doesn't do, which I think is actually a plus because it keeps the serverless framework focused and simple. So if I want to add some other resources like a database or talk to other servers or things, I need to specify some of those things myself, which means I need to learn a little bit of CloudFormation. So first, as a helper, we're going to add some variables to our serverless.yaml file. We're going to create a custom section. And in that custom section, we're going to define like a user table. Now, this is the serverless YAML variable syntax. This is the thing. So here, self means this file. You can also point to things like S3 or an external file. So you can pull in like environment variables, or you can pull in command line arguments, or you can pull in secrets from another file. I like to store secrets in S3 and pull them in from S3, which means you need to have an internet. Well, you always need to have an internet connection when you deploy, but it gives you a kind of a secure way to store secrets and share them with team members. So this is saying, this refers to self-provider. So this is the provider section and then stage. And notice that stage has its own variables. It's going to get whatever the stage option is, which if I go back is serverless. I do -- stage, and I can do dev or I can do prod. So it'll get whatever that is first. And if it doesn't have that command line option, it's going to grab this default stage. So I have these different variables set. Now, why am I using stage in the user table name? Well, because when I deploy to dev, I want a different user table than when I deploy to production. So it's actually going to create two separate tables. It's like creating a dev database and a production database, and they're named slightly different so that they're separate resources. If I create an S3 bucket, it needs a globally unique name. And since I've used this name, if you guys try and use this name on your own, it's going to give you an error. So you're going to have to come up with something else. So I have the user table and the user bucket defined. Now I can add that DynamoDB table. So there's a section in your serverless YAML file called resources. So that's the serverless key. And then under there you have an what do they call that? Upper camel case, where the first word is also uppercase. Resources. That's the CloudFormation key. Then you have all your CloudFormation resources. So I give it a name. That way I can reference it elsewhere if I need to. The type is DynamoDB table, and I give it properties. So the table name, I reference that variable. So the table name here is serverless user store dev user. I have to set up attribute definitions. The only attribute definitions I need to set are for my key attributes. And so I have a ID, it's a string, and that's going to be what's called my hash key. I'm not going to get into a lot of details with keys, except just I have some notes here that there's 1- and 2-part keys and a lot of further reading about Dynamo. If you're really going to get into Dynamo, I strongly encourage you to read this best practices document and know what Dynamo is good for and what it's not. It's an auto-scaling database that's NoSQL, but if you don't design it correctly, it won't perform well for you. If you do design it correctly and it fits the use case, it'll perform awesome. So, pay per request. That not only sets the billing mode, but it also makes it auto scale so that the only time I'm ever paying for Dynamo is when a request comes in and it just scales based on the demand. You can set it up so that you pre-provision read and write capacity. And there may be some cases where that's cheaper, but most of the time this is going to be cheaper because it just manages it for you and it's really slick. All right, here's how to add an S3 bucket. It's even simpler. It just has a type and a name. Again, it just needs to be globally unique. So here's the gotcha. I've added these resources now. I'll show you an example. If I go to, let's see, I'll just go to my text editor. So here's an example of a number of resources that I've added. So I've added all these resources, but my Lambda function does not have permissions to access any of them because Lambda functions only can access what they are told to. So in addition to adding the resources, I have to add some permissions underneath the provider. Now this is the root level provider. I'll show you what I'm talking about. So, so this root level provider where we specify the name and runtime. We need to add this key, IAM role statements. And I'm gonna say, I want to allow these actions. I'm using really fine-grained control. I can go DynamoDB:*, and then it can do anything, any action. But specifically this one, all it does is it gets, puts, and deletes items. We're not listing or querying or anything else with this certain example, so I've excluded those. And the resource, again, I could have just put star at the end, but I want this to be restricted to the one resource that I actually wanted to access. So this is just best practice to keep your permissions fine-grained. These stars here, one is for region. So this will, AWS has a bunch of different regions, like in the East, the West, in Europe, and China. They're different data centers. So I can specify for a specific region. I almost always use US East 1 since that's their main data center and the most well-supported. But I just keep this as a star because that doesn't really matter to me. This is where the account number would go. If I put in my account number, it wouldn't work for you. But this is at least usable for you guys to use. All right. And besides, even if I put an account number that wasn't mine, it wouldn't give me access to that because it's not my account. Because this is deployed on just my account, so it's really the only thing I have access to anyway. So a star is fine right there. Similarly, I have these S3 bucket permissions. All right. Further reading there. Now that we have these resources added, so let me show you that a little bit more. If I deploy this, instead of just deploying my Lambda function and the API gateway setup, it's also going to deploy all these resources. In this file, I have 3 DynamoDB tables and 1 S3 bucket. I'm going to deploy all those resources when I hit serverless deploy, and it's going to set all the permissions. So let's see, it's going to be one more. So I'm going to go ahead and do that while we're talking. And the first time I do it, it creates the resources. The next time I do it, it updates it. And it's smart. So if I remove one of these from my file and then redeploy, it'll remove that resource. If I rename it, there's some things that you can't do on an update, and you'll just get an error. But if I remove one and add a different one, it'll just do that. Some resources can't be renamed, or reconfigured after they're created. At least some parts of them can't be. But this makes it so everything deploys all at once. If you're curious of what that looks like, I can go over to my console. Oh, and remember the complexity of AWS? When you have an AWS account, if you look at the services menu, these are just, and it scrolls too. These are all of the different services and stuff that AWS offers. It can get really complex really fast, but I'm going to go to Cloud Formation. No, not CloudFront, Cloud Formation. And it's going to show me that this thing that I just deployed is currently in progress. So that's what serverless is doing. It's doing this currently in progress. And if I look at the events, it'll show what, resources better. It'll show all the things that it's deploying. And it's pretty cool that it just manages all that for you. And there it is, it's deployed. So that set up all my databases and tables. All right. Now I want to access that database in my code. So here's just a quick example. I need to install the AWS SDK, but I do that as a dev dependency because the AWS SDK is included with all the Lambda official, all the AWS official runtimes. So since I'm using the Node.js runtime, it's included, so there's no reason for me to bundle it in with my code as well. So I just have it locally. And this is an example of how to access DynamoDB, where I create a document client and then I do a db.get. Again, this is really where TypeScript and VS Code really come in handy. I'll show you an example. So I have this in a file called the DynamoDB object store. So we were just looking at this db.get. If I command click get, or if I hovered over it, give me this documentation, I want to click into it, it shows me that the parameters are get item input, and the return type, if I scroll over here, is a get item output. And if I want to click on either one of those, I can see without having to Google and look up all the documentation what that's supposed to look like. And similarly, I can look what the output, here's the output, what that's supposed to look like. So, and it also gives me, let's see.
Josh, can I interject really quickly?
Yep.
I know some of you Swift developers are yawning and saying, oh, this is like, we have this is Swift. But imagine if you were doing this in JavaScript, because this doesn't exist in JavaScript.
No.
You have to go read the documentation, and Amazon's documentation is not easy.
Let's see, where was I? No, it's not. So, and it gives me autocomplete. So if I just start doing stuff there, okay. But one of my frustrations, ever since Swift came out, autocomplete hasn't been quite as good in Xcode, unfortunately. I hope they finally totally fixed that. Okay. So where were we at? So there's an example of working with DynamoDB, and here's an example working with S3. So here, now it's going to get more complex pretty fast. And this is, we can go in and look at some specifics. I've talked a lot. We can answer questions or go into parts that you guys are interested in. But basically, if I jump out of here and go into the next part, it talks about all the Lambda functions that I've set up. It shows my new index, which has 4 of these handlers, one for the API, one for other things, one for custom authorizer, and one for WebSockets. Let me talk through that just really quick. The authorizer function. I have a function that checks a JSON web token to see if the incoming request is authorized or not. And I have that attached to the HTTP API handler. Now here, I have two triggers. One is API slash, and the other one is API slash, and then this special proxy variable. Basically, this means that anything at API slash and after will get handled by this. It's a catch-all. And so it means that anything under API is going to have to be authorized with the correct token. This HTTP handler, I just have it slash, and that could be slash or not. So this is just the root. And this is not authorized. And I have a WebSocket handler. I talk a little bit about why I do the authorization that way. I also use the express router. That's really commonly used in Node.js projects. I like using it in my serverless apps because even though I can define routes here in my serverless.yaml, I like to instead define these catch-all routes and use the express router because it just decouples my code a bit more from API gateways, syntax, and their specific routing conventions. And it just gives me more flexibility. It just lets me add new routes right in my code, lets me add my own 404 and other error handlers where I can't do that if I specify it all in API gateway.
Would an alternative approach, would you have to specify like all of your routes here and there would be a separate Lambda function per route?
That's correct. Yep, an alternative approach. Now, there'd be a quote unquote separate Lambda function. It could still point to the same code base or even to the same handler. But so each API gateway call automatically spins up a Lambda function. So it could be one that's run before, it could be a new one. By default, AWS gives you 1,000 concurrent Lambda functions. I've tried to, and since Lambda functions run around 1 to 200 milliseconds for HTTP requests like this, it's really hard to get up to 1,000 concurrent. And you can always request an increase, but that's a lot.
It seems like you'd also maybe run into situations where paths that aren't used very frequently, the Lambdas would turn off, and you'd have, because cold Lambdas are a problem, right? If your Lambdas aren't warm, then you have to wait for them to get started up.
Yeah, that's true as well. So yeah, this is just the way I like to do it. Like Derek said, you could define every single path here in your serverless.yaml. You can break it out into separate YAML or JSON files and import them, but it gets messy, and I just prefer doing it in the code. So to give you an example of what that looks like, I'll jump over to the code. I have this thing called an API router, and my routes look like this. I have a get route at /user/self. I have a put route /user/self, and a post route user self action. So so that's my routing. Now, there's a lot of stuff that happens in this code. I'll just talk through some of its features. It has the base router. It has it currently has two endpoints. One, to register a new user. This takes in an ID and a password. It hashes the password into a password table with salt and SHA-256 hash function, and it creates a JWT token, which is signed by a secret that I also store. So I'm doing a lot of stuff for you. If any of you ever want to use this in production and have questions, just hit me up to know exactly what I'm doing. I'd be happy to go into some further detail. And that said, of course, it's with a license where it is as is, and what do they say? They always say it's not, no warranty expressed or implied. But I am happy to help and explain and show you what I do know. And I have used this code in production. So if you have specific questions, so this allows you to create users, log them in with a password. I do not have token refresh. If you need to, instead of refreshing the token, you just have to log in again to get a new one once it expires. These tokens last for an hour. These endpoints are just for self. So all this does is this allows me to, for a user to store their own data and get their own data. Okay, this isn't querying users or managing users or any of that. This is just a user store. So it takes the user that was authorized, and from their token, I decode the JSON web token and I get the ID, and it shows up here. And that way I can get the user from the database. And I can show a quick little example of that. So if I want to, oh yeah, so last time I did this, I had an expired token. So let's log in and get a new token. All right, I'm going to grab this token. And when I get the user, I'm going to replace this. The new token, and get that user. So there you go. Let me get the user. A put replaces the user completely. So whatever you have there will be replaced. It doesn't do anything smart like syncing or anything. But because of that, I have this action set up. Now let me talk just really briefly about actions. See, I'm going to go back to my code here. So Derek, you should find actions familiar because this is Redux-like. I like unidirectional state flow, and it's not for everything, but when you're dealing with something like global state in a mobile app or a web app, or you're dealing with a single user, it's a good way to just update things in a predictable way that's easy to test. And so I go into that a little bit here in chapter 6. I have stubbed out this file where you can add your own actions and extend this reducer. So for example, this is what I would do if I wanted to be able to add things to a user. So let's say a user so with my work, we're doing autonomous lawnmower. So a user has a lawn, and a lawn has zones, and all of these are attached to the user object. So I'd have an action that is an add a zone or add a lawnmower, and things that I'd want attached to the user object. And it just stores it as one big blob. And as long as that is just represents the user's data and isn't highly relational in nature, going to be queried by other things. So if it's an app with a simple use case, it just needs to store users' data, this is a good fit. If it's not, then there's other patterns that are better. But I have some links here on how to write actions and reducers in a way using pure functions and unidirectional data flow patterns. And it's a personal preference. You don't have to do this way. If you want to kind of manage things yourself and always do that put, so it's always replacing the user object, and you're confident about not putting a null user there to delete it, then that would work for you with your app as well. All right, lastly, I have some other resources that you can look into. If you want to create a custom domain name, AWS will give you a free SSL certificate that they manage for you. And this goes through stuff to do that. If I want to be able to look at these records, oh, I didn't do a new line. Need to fix that. But in the console, I have, a way to look at DynamoDB records. So I go to my tables. This is my password table. And here you can see, I don't like the tree view, I like just the JSON. You can see what a hashed password looks like. And I have subscriptions for WebSockets. Oh, I can demo that too really quick. To demo the WebSocket subscriptions, I need to, let's see, I'm going to go to my root. I have a little, here in my root README. Let's put this all together because I deployed this and I have this WebSocket endpoint. And I need to do wscat, which is a tool, a command line tool that I installed. Do this, set the authorization header to the token that we had here, if you remember that when I logged in the user. So I'm going to put that token there. I'm going to grab this command and stick it in my terminal. Okay, this WebSocket client is now connected to API Gateway, and API Gateway is keeping that connection open for me. So when I'm going to have to, if I put the user, I'm going to have to update this token too. Okay, if I update the user, then what did I do wrong? Well, take my word for it. Nice little demo problem. Oh, I know why. No, that's the right URL. I can double check that it's the right URL. Let's see. My URL was this. I'm going to replace that. Oh, I need the not the slash at the end. No, it's still not working. The get was working, so I'm not sure what's wrong, and I'm not going to debug it in front of you all right now. But once that got pushed, I'd get a WebSocket notification there. Oh yeah, something important. We're going to go back to the guide here, and I'm going to show you something that I skipped here in the final code. Is the final architecture. So this is what we've deployed. I have 3 different graphs here. One is for that authenticated endpoint that I showed you. Another one is for the non-authenticated endpoint, and one is for the WebSocket. So the authenticated endpoint, it talks to API Gateway. API Gateway can call a separate authorizer Lambda function, which authorizes the user. That function can talk to this DynamoDB password database. If that succeeds, an API Gateway will then call the application Lambda function, which can talk to these different data stores. It can put stuff in CloudWatch logs, which it does automatically when you log to the console. And it can also post an API gateway message. And what it does is it looks up the connection ID in this subscription and posts it to the appropriate WebSocket for that user, if it exists. So that's for that one Lambda function. This Lambda function doesn't have an authorizer, and it doesn't post WebSocket messages, so it's simpler, but it does interface with the DynamoDB password table because it creates users and it logs users in. And then the WebSocket one looks like this. It maintains a WebSocket connection and updates the subscription table and can log. So that's the entire architecture that this root project has. Now I want to take a note that this Lambda function is a separate executing piece of code than this Lambda function that will post back to the WebSocket. So where the WebSocket connects and where the WebSocket then receives data are handled in two different Lambda functions. You need to think stateless and event-based when working with serverless with these async things like WebSockets and other persistent connections, because it's not like your typical server where you can just have the state of the persistent WebSocket right there ready for you. You have to save that state somewhere, which I use the DynamoDB subscription table for. All right. Any questions or things? And after we do questions, there's some stuff that I'd like to work on that I could add to this, like mobile push notifications. That's kind of one of the biggest ones that I wanted to add, but I didn't run. I ran out of time to do. But there may be some things I'd be interested in adding to this if anybody is wanting to use it.
Joshua, is that Dynamo subscriptions table, is that something you built?
Yes.
Okay, so that's not like a standard, if you're doing WebSockets with API Gateway, they provide this?
No, it's not a standard thing. All API Gateway does is it provide you a connection ID. And you need to take that connection ID and persist it some way. So I actually created what's called an API Gateway WebSocket subscriptions class, and this subscriptions handler that makes the whole subscription flow reusable outside of this code. And actually, all of this stuff under lib are reusable components that you can just put together. So like these object stores, the API Gateway, the Express class. So the Express class, for example, doesn't have any routes defined. You just pass in the routes, and these are just things that I use commonly and fit a lot of common use cases. So anything under the lib directory is meant to be. Oh, and there's one more thing I need to show you guys. The main user store. I actually set it up so that you can do that either in S3, where it just saves a file that's a JSON document that represents the user, or DynamoDB. Why did I do this? Well, DynamoDB has size limitations. So if you're dealing with a user object that's larger than about 0.5 MB, now with JSON, that's quite a bit, but still, if you're doing a larger user object, you'll want to use S3. S3 could be a little bit slower, but in my tests, both were pretty quick. So round trip time with this whole thing. In fact, let's look at it. This is getting from S3. That one was 558 milliseconds. That was kind of slow because the function was probably cold. If I redo it, it's closer to 300 milliseconds. If I were to use DynamoDB as the backend, it would shave off maybe 100 milliseconds. Any other questions?
Another question, sorry if I'm asking all these questions and nobody else cares about what I'm asking about, but GraphQL, is that something you would have to set up your own Apollo server and run it from your Lambda, or does serverless have a way that you can provision GraphQL servers within AWS?
Well, I'll show you how I would do that. At least I'll show you the start of it. What I would do is I would go yarn add, and I just include the GraphQL.js library. Oh, it doesn't have autocomplete. And then there's no need to have an Apollo server to do GraphQL. All you need is the library, and I can run that in my own Lambda function, which I have before, where you can, so GraphQL is just another HTTP request, right? So just like I have that catch-all handler that routes to Express, I would have a GraphQL endpoint that would be handled by the GraphQL library and then interface with my database. In fact, I thought about putting a GraphQL interface in with this, but there's lots of things I thought about doing that, you run out of time. Because GraphQL is just another option that you could use. But yeah, serverless handles GraphQL just great.
Cool.
Question. Can you talk about the size limitations / costs associated with DynamoDB over S3?
Yeah, so I can't talk to a lot of detail. I need to do some testing, but they have these pricing structures. So we're using on-demand mode, and it shows you that, oh, this is different than it used to be. Your first 25 gigabytes of data storage is free, and then it's 25 cents per gigabyte afterwards. We need data transfer. That's the data in and out. So data out, first gigabyte's free, and that's forever, by the way. That's your next terabyte, or that 10 terabytes, almost 10 terabytes is 9 cents per gigabyte. And then I just have to compare that with the S3 cost. And we see that S3, as far as both data storage, let's go to US, it's probably the same price. Data storage is cheaper. And where do they have their data transfer? Here it is. And data transfer, though, is the same. So, yeah. So the storage costs would be cheaper on S3. Now, that said, I've run production projects with thousands of users, and DynamoDB has ended up costing me maybe $30 a month. The nice thing is if it's a demo project or just something you're building in-house, until you ramp up, it can cost you like pennies or nothing if you're under the free tier limits a month. And those things are nice. I'm going to turn on the light since it's getting dark. That's not a ton of lighting, but a little bit more.
So is there a way to put a hard limit on that free tier so that if it goes over, they don't charge you, or is it just, you just got to make sure you don't go over it?
Yeah, I don't think there's a way. So AWS has hard limits, but they aren't set at the free tier level. And those are there to protect users in case they get a denial of service attack or they don't set up something correct. And those limits can be extended when you explicitly ask them to, if you have a very highly scaled production app. So they do have some protections in place, but I don't know of a way to limit it to the free tier besides just monitoring it. They do have alarms though, so you could set it so, all right, if I've used 80% of my free tier quota, then send me an email. That you can do. And I bet you, since they do have those alarms and those are event-based, you might be able to do something to automatically shut it down, but you'd have to build that.
And then they'll get the email in the middle of the night.
Naturally.
Another question. How would I go about importing large amounts of data into something like DynamoDB?
The way I've done it before is I've scripted it, where I just created a command line tool that just goes item per item. DynamoDB does have an import tool. Let's see. I'm not sure exactly where it's at. I haven't used it a lot. Oh, by the way, in my DynamoDB notes, it's easy to turn on automated backups. Let's see. I forget where that's at, but I linked to it. S3 is a little bit easier. There's the command line tool to import stuff.
Yeah, because like S3 is basically just like a remote file server. So like with S3, I can use an app like Transmit to just log into it and browse through the files. But DynamoDB is not. So
I haven't done that with S3. If you set it up that way, you'd have to explicitly set those permissions to do that. I've only interacted with S3 through like the SDK and the CLI, or the console where you can just drag and drop. Oh, I should mention that I do consulting with this. If anybody's interested in doing a big project, want to know how to put it together. Any other questions?
Just one about security. So you talked about secrets, keys, and stuff. How secure is this for me to put my users' data up into the cloud like this? And if I have to put some sort of keys or secrets up?
Okay, so it follows best practices. Now, there is something that I wanted to do for this that would offload the burden off of me a bit, and that is to use the Cognito service to generate keys and stored passwords. And I might get around to being able to do that. What I did is I used best practices with, let's see, where's my, I use best practices with the Node crypto module, which when I get a password, it uses the crypto module to see the digest, uses a SHA-256, assault, and creates a hash and uses 10,000 iterations to hash the passwords. And then I use the JSON Web Token library and a 256-bit randomly generated signing key to create the individual JSON Web Tokens. So it follows best practices. This one is one that I wrote myself. It's fairly well tested, but again, it doesn't have any warranties or guarantees. Now, it would, but if I were to use something like Cognito, I would offload that burden onto AWS. Cognito's always been a little bit tough for me to deal with since it's just kind of convoluted, but I've dealt with it a bit in the past, and I wanted to put just a simple interface like this in for it. Also, everything is over HTTPS. And what you're doing is you're relying on the security of API Gateway, DynamoDB, and Lambda. And because of our access controls, because we're only allowing this thing, these are deployed in a secure data center, protected by AWS firewalls and all of that. And And the access controls means that it's very limited into things that it can talk to. And because we use those access controls, I don't have anything else here that can talk to it on this service managed by those access controls. So I've had really good success so far with AWS security. And does that answer your question well? Do you have any other security questions?
Yeah, I mean, it's mostly who do I trust, I guess. It would be nice to have this all in like an encrypted container where no one has access to it except for, I don't know who, I don't know how you would have the key on the server to decrypt it and run it. But it really sounds like we just trust Amazon and that's the closest or the best that we can do at this point.
Well, there's a little bit more that we can do. One, I can encrypt the database. I can turn that on.
But your key will be on their server.
Well, it could be, but I could actually store the key on my own server and then set up a tunnel for them to access it. So like I said, Amazon is super powerful and configurable, and there's a lot of things that I can do. So I could trust Amazon, and I could store the key in their key service, which is better than not having it encrypted. Or I could not trust Amazon and still have a key, but have that key somewhere else that I store. I can encrypt my S3 tables. I can do end-to-end encryption if I wanted to in my application code, all sorts of stuff, just like anything else. So, and if you're interested in it, Amazon has great documentations on security, including their shared responsibility model. Responsibility model, AWS. And they talk about what they take care of and what the customer is supposed to take care of. And I've done apps where we've done like HIPAA compliance and entered into an agreement with Amazon to share the security burden and stuff like that. So there's a lot of resources, and Amazon is in the business of protecting your information and providing you tools to be flexible.
Cool.
So Dave, do you think this is this in the realms of what you were hoping for?
Yeah, this is great. This is really interesting. Like I mentioned before we started, I've got a little bit of experience with setting up this sort of thing just because I'm using something similar in my own app. But I've learned a few things. I've learned that I am vastly over specifying things in my serverless.yaml file because I've got every possible HTTP endpoint listed out there. So it's nice to know I can just kind of have a wild card in there and then take care of the rest in code.
Yeah.
That's been great. I've been really fascinated to see how I can kind of do this hybrid model between DynamoDB and S3. That's also really fascinating to me. So this has been great.
And the S3 bucket that I've set up has no outside user permissions, because you can set up S3 buckets that serve up a static website and have public permissions. It's easy to do that and to share files with other people. This S3 bucket that I set up is totally closed off from everybody. And so it's only accessed by my application code, which I explicitly gave it access to. I've also set it up where my application code writes JSON files to a public bucket, which then is accessed from the public website because it's public data, right? So there's lots of options too.
One of the things I am doing with my particular backend is that I'm also using Route 53 to access my Lambda functions in the API gateway through a custom domain, so that I don't have to hard code that bizarre, 66ZNT 8K whatever domain into my app.
I do the same, and whether using Route 53 or another DNS, I don't know, if I do Namecheap. But what's the one that everybody hates, but so many people use? GoDaddy. Anyway, so whatever DNS or name registrar that you're using, these steps let you create. So one thing about API gateways, it requires all traffic to be HTTPS. So you either need to use this convoluted URL, or you need to set yourself up with an SSL certificate specific to your domain. But AWS makes that free and pretty easy to use. And here's the instructions on how to do that. So.
Yep. And with my backend, I actually find that the most significant cost of my month-to-month bill is Route 53, because I believe they've got like a hard or a fixed price of 50 cents per month for the domain name. So I think that means that my bill per month ends up being about 63 cents.
So that's actually a reason why I don't use Route 53, because other registrars are cheaper. But like you say, your largest bill is not very large.
Yep.
Yeah, I've found the free tiers to be incredibly generous as well.
What's more is AWS has a startup program where you can qualify for $25,000 in credit if you're starting a new business. My current business has that, and I've worked at a previous startup that got that as well. So there's it really can help you get jump started.
Is that available to anyone? So like if I'm a one-person dev shop, could I get that and like pay for my AWS costs for the next millennium?
Well,
They've got
it expires after 2 years, but anybody can apply for it. And I'll look it up and post information in the Slack. All right.
Cool. Any other questions from anyone?
If you wanted me to add something to this, because this is a very interesting project to me, and it's stuff that I use. So adding a few things to it, I'd still use. I'm just curious what people might want. I talked about push notifications. I talked about integration with Cognito. This is focused on being a user store, so it doesn't have like a SQL database and more complex relationships and stuff like that. And I don't know if I want to extend this one to that, but just curious what people are interested in, if anything.
I think like what was talked before, like seeing a GraphQL implementation for this would be great.
Okay, that's actually pretty easy for me. So basically, I would just provide the same functionality that I have with my Express router with GraphQL definitions and types.
So another thought, and if you're thinking of delivering this presentation to a different audience, maybe this wouldn't be that interesting. But I think for this audience, it might have been cool to see, like a simple mobile app that's talking to your APIs that you're building. I mean, I suspect everybody here has probably done their fair share of REST and GraphQL, so maybe that wouldn't be too interesting. But it's always kind of fun to see, the rubber hit the road, so to speak.
Yeah, put together a little NSURL session demo with the REST APIs, and yeah. That reminds me of AppSync. So AppSync will like create a cross-platform build of, I think they do React Native apps and different things like that, and all this stuff that it's supposed to do for you. But I've never, it's one day maybe I'll really get into AppSync and figure out how to.
I did a little bit with AppSync, and one of the things that I thought was really cool is that they have like an in the console web experience where you can actually build, based on your schema, you can actually connect a single resolver to a single Dynamo table, and it just sort of magically does things for you, which is pretty cool. But I didn't actually get anything usable out of it, mostly just kind of tinkering.
Well, and they have some cool stuff where they will create a whole GraphQL API hooked up to Dynamo and just auto-generate a bunch of stuff based on a schema. But it always feels a little bit more complex than it would have to be. But it's awesome stuff. I mean, if you figure it out, there's really cool stuff you can do with it. I love AWS for what it can accomplish.
Yeah, it felt to me like they were trying to be Firebase, but Firebase is very very proprietary and very, like Firebase, the real-time database is pretty incredible, but at the end of the day, it has some really crazy limitations because it's just a giant JSON store. But that's what it felt like, is that they were trying to be Firebase.
But Firebase has also been more successful at being easy to set up more than AWS stuff. So like you said, it has its limitations, but it's easier to set up. The tutorials are easier to follow. But if you want something more powerful, then AWS gives you a lot more options. That said, Firebase is expanded into file storage, and you can use Google databases and a lot of other things. So you can also hook it up to things that have similar power, but the Firebase store is for certain use cases.
So that actually raises an interesting question for you. I know some of the stuff that you showed us in your serverless YAML file was very AWS specific, such as the Dynamo configurations. But like your really simple hello world, could you just change it to Google Cloud or whatever instead of AWS and deploy it, and it would just use their cloud?
No, there's actually one caveat, and that is, in fact, if you'd like to know, I can show you really quick. It's really fast. Let me share my screen again. There it is.
At a broader level, Derek, serverless aims to be agnostic of the backend as much as possible. There are specific things that you can do to, like, say, when you're deploying to AWS, do this, and when you're deploying to another service, do that, which is where those AWS specific things come in. But it does plug into different backends.
So here's the only problem with deploying the same code, and that is this function signature. So here with AWS, I get an API gateway event. Azure and Google Cloud Functions use the express syntax where it has, request. I'll just do any for here, and response. And then I would do request.send hello world. So that's the only incompatibility, which I prefer that syntax.
Yeah, that's interesting.
But AWS does their own thing.
Cool. Yeah, this has been really helpful. I know I've experienced going into AWS and saying, okay, I want to do X, and just being confronted with this giant
so much stuff
and so many services, and I don't know which ones to use. And not only that, even if you do figure out that you need a Lambda and you need API gateway, and figure out how to create a route in API gateway and have it invoke this Lambda, you still have the permissions to deal with.
Right, and then you try and run it and it doesn't work.
Yeah.
Yeah.
And also the process of just setting all of that up manually is so tedious.
Yep. Well, thank you, everybody.
Yeah, thanks, Josh. That was really, really awesome. Thank you.
And that repo is there. If you guys want to jump into this, there's lots of links and further reading.